Hey guys, my name's Logan and you're watching Design Space. Today I'm going to teach you how to wire a DC motor into an Arduino and control the speed using a thumbstick. I'm going to go over wiring using jumper wires into a breadboard and the writing of the code. It's all really simple, and everything I'm using in my video today I got from this starter kit off Amazon. Came with all the basics I needed to get going. So if you're looking to get started in Arduinos, it's something I'd recommend to you. And let's get into it. Okay, on screen is a draft of the wiring we're looking for. I did it in Autodesk Fusion 360. I think it's going to be way easier for you guys to follow along on screen rather than me wire it in person with my hands, because they're just going to get in the way. You're never going to know what I'm doing. If you have the same components as me, that's what you're going to end up with. And if you don't, you should be able to grab a data sheet and still apply the knowledge to whatever your project is and get it done. So, the first thing that we want to wire is the joystick. Left and right movement is the y-axis, and we're going to run VRY output from the joystick to analog input pin A1 on the Arduino. We're going to run VRX up and down movement to analog A0, and then we're going to run ground to ground, and we're going to take the 5-volt output from the Arduino and we're going to run it to 5-volt on the joystick to power it. While you're at it, you can ground your Arduino to the breadboard. Make sure you note which channel you're in. And I got that wrong before. Wiring the Arduino to the L293D motor driver. We're going to take PWM pin 5 and we're going to run it to enable 1 on the motor driver. It's going to determine how much voltage and which direction our motor is going to turn at. So if you take a look at your, if you take a look at your motor driver here, it's got this cutout, and to the left of the cutout, that's enable 1. If you want to wire a second motor, enable 2 is here. It's in reverse. So make sure you're not wiring them backwards when you follow along. The next signal from the Arduino is 4. It's going to be an output from the Arduino, and it goes into input 1 of the L293D right here, pin 2. Pin 3 of the L293D, this is output 1, and we want to send that to an available row on the breadboard. It's going to power the motor in one direction. The next 2 pins, 4 and 5, are both grounds, so ground them to the breadboard, it'll be fine. Pin 6 is output 2, so the other direction for the DC motor. Again, find an available row on the breadboard, let it sit there. The final signal coming from the Arduino, an output from pin 3 there, is going to 7 on the L293D, which is input 2. And the final pin, pin 8 of the L293D, is your source, your 5-volt source. So grab that from your power module. My power module looks something like this. And again, it came with that starter kit. But whatever you're using, just make sure you've got it plugged in properly. Plus, plus, minus, minus. The next step is powering your DC motor. So these 2 wires determine which direction your motor's spinning the inputs. So wire those to output 1 and output 2 that we left in available rows on the breadboard. If you followed along your setup, assuming you have the same components as me, it looks like this. And next I'll get into the coding of it. We'll get a real video of it running for you guys, and then we'll wrap this up. All right, on screen is the code to power this motor. I'm gonna go through it step by step with you guys. If you follow along, it's gonna work out just fine for you. First thing we want to do is define the pins on the Arduino. Now 3, 4, and 5 are all signals that we're sending to the motor driver. So you can pick any variable you want. I picked motor forward, motor backwards, and enable because they just made sense to me. As long as you're consistent throughout your code, you can pick your own variables if you want. We're going to define 2 integers, motor speed and X speed, and they're going to relate to each other later in the code, but for now we just want them set to 0. Now our void setup, so the code that runs one time before the loop of the Arduino code starts, that is where we're going to define these 3 pins as outputs. So we go pin mode, variable name, output, all in caps. Repeat, repeat. And then we want no signal being sent to the motor at the very start of our setup. So we're going to make sure that that enable pin is set to low. So it's not sending out any power. And to get a serial monitor showing so that we can make sure our signal from the joystick is being interpreted properly by the Arduino, we're going to write this piece of code, serial.begin 9600 in brackets. The next step is the loop. So this is the code that is going to repeat continuously while our Arduino is running. So the first thing we're going to do, we're going to define another integer, joyx, as analog read A0. It's going to read whatever signal is being sent to input A0 of the Arduino. If you recall, that's the up and down motion on the joystick. And we're going to print that value to our serial monitor. This piece of code here is going to do that for us. It's going to print x-axis, this just wording, then this integer number, and then it's going to give us this bit here is going to give us a blank space just for convenience. It makes it a lot easier to read. So the way the analog read works is when our joystick is straight up and down and we're not pushing on it, it's sending out a number at 511. 511 is going to show up on your serial monitor about. And when you pull it all the way backwards, your serial monitor is going to read 0. And when you push it all the way forwards, the serial monitor is going to read 1023. Those are the signals coming out of the joystick. So to work with that, when we're between 511 and 0, we want the motor spinning in a certain direction. Same with the other way. When we're 511 to 1023, want the direction reversed. And the way our output pin works, the enable pin that we're sending a signal out from, its bottom is 0 and its max is 255. So our joystick's straight up and we're reading 511. As we pull it backwards to 0, we want our enable pin sending out an increasing signal from 0 to 255. We want our signal to be 0 at 511, and we want it to be 255 at 0 on the serial monitor. So that's what this bit of code right here is going to do for us. So our motor speed's saying when our joystick moves from 450 to 0, this variable is going to increase from 0 to 255. So hopefully that makes sense. And Our digital right, we want motor forward, so just direction 1 high and direction 2 low. And then if we move our joystick past 511, so from 511 to 1023 down here, again we want our signal sent out from the enable pin to be increasing from 0 to 255, so maximum power at 1023, just like we had maximum power at 0 at full joystick movement. And we want that to be motor backwards. We want the other direction there. Now I realize these numbers aren't 511. I just give it a little bit of breathing space so that it can deliver the power necessary to turn the motor. So anything in between 550 and 450, I want motor speed 0. I don't want any power going to the motor. And another safety buffer in there is if this value here and here comes out less than 70, again, I want my motor speed to be 0. That's because at those powers, from 0 to 70, your motor's not going to spin, or mine doesn't. It just makes a whining noise at me and it's lacking power. Test out what works for you. If you have a wheel on your motor, that number could be higher. It's going to take more power, more torque to turn the wheel. So the final step here is to write motor speed here and here to enable on the motor driver. So that's going to determine which direction and how much power our motor is getting. And that's going to make it work for us. And then we just want to set a small delay before this all repeats again, as long as your Arduino has power. So hopefully that all made sense to you guys, and let's get this thing running. So if you followed along and my instructions were good, hopefully you were able to get to this point. What we've got here is the joystick, the Arduino, the L293D, power supply, and a DC motor inside this little 3D printed assembly. So also on screen is the serial monitor. Our joystick is straight up, no movement, and the serial monitor reads 511. As we move the joystick, you can see that number change, and we start to send some power to the wheel. The more we move, the more power goes to the wheel. And then back to center, no movement. And then the other direction, we get the same effect. Wheel spins opposite, and the serial monitor goes to 1023 full power. Hopefully this has worked out for you guys. We're gonna go up to the face cam and wrap this up. Thanks for watching the video, guys. I hope you were able to get your project up and running. If you liked the video, subscribe to the channel so I know you want more content. I'm going to do some stuff with the 3D printer. I'm going to do some projects in Fusion 360 and just show you some design processes start to finish. Hopefully inspire you guys to get out there and do some of your own designing. And I'll see you next video.